Okay, so we're going to talk about Euler formula. And the whole idea is to prove one thing, that the absolute value of the Euler formula is just 1. Now remember that the Euler formula is defined by e to the power of I theta equals cosinus theta plus I sinus theta. This is the formula. And if we remember, if you take a complex number and look for its absolute value, you look on the complex number and look on its coefficients, x and y. Now the absolute value of this z will be the square root of the sum of the squares of the coefficients. Now in our case of the Euler formula, we have x equals cosinus theta and y equals sinus theta. Plugging them into the formula, we get that the Euler formula absolute value equals cosinus theta squared plus I plus sin theta squared. The I is not here. And when we take this square root of this, we'll get the absolute value of the Euler formula. But remember that cosinus squared and sin squared, when you sum that all up, there is an identity that says that this is just 1. Therefore, you get that the absolute value of the Euler formula is just the square root of 1, which is 1. It means that for every value that you'll plug in for this theta right over here, it will always stay 1. So it's on the unit circle. It looks like this. For every theta that you will define, the distance from the origin of the Euler formula will always be 1. And this is how the Euler formula is related to the unit circle. And with this, we summed it all up. The Euler formula absolute value is always 1.